In this tutorial, the 8-pin PIC12 F1572 will also be programmed to switch on an LED connected to pin 5 RA2, as in the previous register programming part of LED tutorial. The PIC device is configured using MPLAB Code Configurator, or MCC, source and header files generated, then the required code added to the main source file and explained. We will also take a closer look at and discuss these MCC generated source and header files. The LED will also be moved to pin 3 or RA4 and the required modifications done to turn on the LED here. This will be done in one part using MCC again, and in another part directly edited in previously generated code sections. The PICKit4 and Snap can once again be used in any of the methods covered previously, PICKit4 powering and being externally powered, and the Snap being externally powered. The LED being toggled on and off will also be covered, as in the previous register programming tutorial, using the default 500 kHz oscillator setup, and then modified to run at 16 MHz after a reset. This done using MCC and directly edited in previously generated MCC files. Check the previous assembly LED episode for any basic processes such as creating a new project, selecting your compiler and programmer, not covered here if needed. Create a new microchip embedded standalone project for the PIC12 F1572. Then select your connected programmer. Finally, select your installed XC8 compiler and give the project a name, say PIC12 F1572 _LED _MCC, and save the new project. The MCC plugin needs to be installed before proceeding. From the Tools menu, select Plugin to open up the Plugins window. From here, the Available tab can be selected and the MCC searched for and installed. If already installed, check the Installed tab to confirm version. This tutorial used the installed MCC plugin version 5.3.0 on the MPLAB X IDE version 6.05. Once the MCC plugin is installed, use the icon or from the top menu, Tools Embedded, and then select MPLAB Code Configurator version 5 to open. Same options used to close MCC at any time to return to the project. MCC Content Manager window opens and a content type selection is presented. Depending on the device selected for your project, certain content type options may be available. For the PIC12 F1572, only the classic type is available, so select this option to open. An online refresh updates any required content, and once complete confirms with the green refresh status block here. With all the content available on the local machine, the Finish button will close the Content Manager window and then open all required MCC windows. Select the Resources Management tab and then the System Module tab to open up the internal oscillator window. For this tutorial, we will select the INT-OSC option from the drop-down menu for the oscillator select. Above this selection, there is mention of the current system clock of 500 kHz. We will leave the default system clock select as FOSC and the default 500 kHz _MF. At the bottom of this window, section Programming, the tick box for Low Voltage Programming Enable can be unchecked to clear the notifications window message. This is only an information message stating that the MCLR pin cannot be disabled when low voltage programming is enabled. Next, select the Pin Module tab, then select the Pin Manager Grid View tab, and from the drop-down Package Selection tab, select PDIP8 to set the package to PDIP8 instead of the default MSOP8 package. The dock symbol here will dock the Pin Manager Grid View window into position and can be adjusted as required by dragging this line up or down. Now with the PDIP8 package selected, the pin module above has the PDIP8 package displayed, and within the Pin Manager Grid View window, the package is also displayed as PDIP8. We can now select the GPIO output row for port A, pin RA2. Note above port A, RA2, there is also the associated pin, number 5. Next, we can give a custom name to pin RA2. Select the custom name column for pin RA2. Here we can modify to LED_RA2. The start high option can be ticked, as we would like the LED to be kept off on startup or after reset. We need to deselect the analog column, as we want this pin to be set up as digital, and the output column checkbox can be checked, set up for output, so to switch on the LED. This will be to 0 for a syncing circuit. The WPU or weak pull-up, the OD or open drain control, and the IOC or interrupt on change options can be left to the defaults for now, as we will use and discuss these in later tutorials. Next we can select the Pin Manager Package Viewer tab. Select the dock symbol to dock into position. This is not only a graphical representation of the PIC device's setup, but also allows modification to pins from here. But we will look at this when setting up the LED on pin 3 RA4 in the next part of this tutorial. For now we are done setting up the required configuration to use the default internal oscillator at 500 kHz. We have selected pin RA2 as a digital and set for an output. No further settings are required. From the Project's Resources tab, select Generate to have MCC generate the configuration and source files for our setup. The output window confirms the process and generation complete. Select the Projects tab and click on the Header Source Files MCC Generated Files folder to open up and display the generated header files. Click on Important Files. A PIC12 F1572 _LED_MCC.mc3 file has also been created. Click on Source Files. The main.c file has been created, in which we will add code to turn on the LED. Click on Source Files, MCC Generated folder, to display the generated source files. Next we can click on the MCC icon to close all of the MCC open windows. Double-click on each of the MCC generated source files for the header files and the source files folders to open up in the editor's window on the right as seen here. We will leave the generated main.c file for last. Now let's briefly look at each source file created. Select device_config.h and minimize line 1 and 24. Lines 47 to 50 are for the device configuration and the XTEL frequency as the default 500 kHz or XTEL_freq 500,000, which we have briefly dealt with in the C part of tutorial. Select MCC.h and minimize line 1 and 24. Lines 47 to 54 includes definition of MCC_h, required header files, as well as 2 of the MCC generated header files created during setup of our project. Minimize lines 58, 71 and 83. Line 69 initializes the device to default states configured in the MCC Graphical User Interface or GUI. Line 82 initializes the oscillator to the default states configured in the MCC GUI. Line 94 initializes the watchdog timer module to the default states configured in the MCC GUI. Select pin_manager.h and minimize line 1, 24, 88 and 100. Lines 47 to 86 defines the pin_manager_h and also includes the xe.h file. There are defines for input and output, for high or low state, if analog or digital, and if pull-ups are enabled or disabled. These are all the options selectable from the Pin Manager GUI previously used to set up pin RA2. There are also aliases defined for pin RA2. For get and set for RA2 bits, we will use later during the toggling of LED on and off. Line 98, void pin_manager_initialize void initializes GPIO and peripheral IO. Line 110, void pin_manager_IOC void is the initializer for the interrupt on change handling routine. Select device_config.c and minimize line 1 and 24. Lines 47 to 64 has the device configuration bits configured in the GUI, with the FOSC field option selected for INT-OSC for internal oscillator used in the breadboard tutorials. Select MCC.c and minimize line 1 and 24. Line 47 includes header file MCC.h. Line 50 has the system initialize functions routine for pin manager_initialize open close brackets, oscillator initialize open close brackets, and watchdog timer_initialize open close brackets. Lines 58 to 66 initializes the oscillator as selectable in the GUI. Although we only left as default after selecting the INT-OSC, there are additional registers available to adjust as required for the OSCON, OSCTune, and BallCon registers we may work with in the following tutorials. Line 68 to 72 initializes the watchdog timer module. This again we left with the default settings, which are adjustable if required. Select pin_manager.c and minimize line 1 and 26. Line 49 includes the pin_manager.h file. Lines 55 to 103 initializes the pin_manager with bits selected from the MCC GUI, for which we will return later to discuss further. Lines 105 to 107 initializes the interrupt on change. Finally, the main.c source file can be selected and line 1 and 21 can be minimized. Line 44 includes MCC_generated_files and MCC.h. Line 49 has the main application void main void, in which we will be adding code to turn on LEDs and toggle them. Line 69 to 73 has a while one loop, with line 71 available for added code. I just leave line 71 with the comment // add your code here for now, and below type in LED_RA2_set low open close brackets : This forms part of the predefined aliases for pin RA2 we had looked at earlier and in the pinmanager.h file. These are available for use for their various functions as defined in the header file. For the LED_RA2_set low open close brackets : the function runs do curly brackets lat a bits dot lat a2 equals 0 : close curly brackets, while open brackets 0 close brackets. The while open brackets 0 close brackets means if false, that is, if lat a bits dot lat a2 is equal to 0 is false, then set it to 0. So the first part of this tutorial is complete. We can build the project, and depending on which programmer you are using, the programmer power can be set to supply power or not. MCC sets the PICKit4 to not supply power by default. So for now I have adjusted the power options for the PICKit4 to supply power, but not going to discuss here, as this has been discussed in the first assembly part of tutorial, which can be referred to if needed. Once the device is programmed and pin 5 RA2 LED is switched on successfully, we can move on for the setup for the LED on pin 3 RA4. Once again, open MCC and select Resources Management tab. Then you will use the Pin Manager Package View tab to open. Now selecting pin 3 RA4 for a GPIO output by right-clicking within the graphical pin 3, then selecting the pin module GPIO output option to set this pin accordingly. The Pin Manager Grid View window confirms this pin has been selected as a GPIO output as displayed, and the pin module now has the added RA4 pin, for which we can change the default name to LED_RA4. Don't forget to also select Start High, deselect Analog Mode, and set as an output, matching RA2. This is the only change we will make for now. Now we generate the modified configuration by clicking on the Generate button. This is confirmed in the output window. We can then close MCC. Now we will have a look only at the files affected by this minor change we done for RA4 using the MCC. Select the Pin Manager.h header file and open or select from the editor's window if already open. Minimize lines 1 and 24. Scroll down to lines 88 to 106. The aliases for RA4 have now been generated and are available to use. Select the Pin Manager.c source file and open or select from the editor's window if already open. Minimize lines 1 and 26. Line 60 now has lat A equals hexadecimal 14, which sets the initial state of RA2 or bit 2 high, and RA4 or bit 4 high. This keeps both LEDs off for the initial state for a sync-in circuit. When only RA2 was configured, the value of lat A equaled hexadecimal 04, which set only RA2 or bit 2 high for the initial state as expected. Line 65 now has tris A equals hexadecimal 2B, which sets both bits 2 and 4 low for direction as an output. Line 70 now has ancil A equal to hexadecimal 03, which sets both bits 2 and 4 low for digital mode. The rest of the registers remain unchanged. Select the main.c source file and open or select from the editor's window if already open. Minimize line 1 and 21. Add to line 74 LED_RA4_ set low, open close brackets colon, which will set RA4 bit 4 and turn on the connected LED. This is all that is required to now also turn on RA4 LED. Build the project, then program the device. The two LEDs will now be turned on. These three files, pinmanager.h, pinmanager.c, and the main C file, are where the same code could be manually added and edited without the use of the MCC to achieve the same result. We can now move on to toggling the LEDs. We can use the aliases already created for both outputs and make use of the built-in XC8 compiler delays to toggle LEDs at different intervals. We will also adjust the internal clock from the default 500 kHz to 16 MHz. Go back to the main.c source file and modify lines 72 to 75 as displayed here. Modify lines 77 to 88 as displayed here. This will switch on RA2 for 200 milliseconds, then switch off for 1 second. then switch RA4 on for 200 milliseconds, and then switch off for 1 second, and the loop will continue. The toggle aliases come from the pinmanager.h file, as discussed earlier. The double underscore delay underscore milliseconds macro come from built-in functions within the XE8 compiler. They can be found by opening pinmanager.h file, selecting line 54 text, xc.h, while holding down the control button. This will open up the XEH file, which on line 24 has the built-ins.h file, which when selected with the control button held down, opens up the built-in.h file. Here on line 22, the double underscore delay underscore milliseconds macro is found. We will be covering the use of and accessing of many such functions and macros in the coming tutorials. Now we will adjust the system clock for the 16 MHz and adjust the xtel_freq for this modification, so to run the same code and LED toggling accurately as done for the 500 kHz clock used previously. Open the device_config.h file. Note the xtel_freq is defined at 500,000. Open MCC and then open the System Module tab. Note the current system clock is still running at 500 kHz, as indicated by the message above the oscillator select. From the internal clock drop-down selection, select the 16 MHz_HF option. Once this has been selected, note the system clock now indicates the adjusted 16 MHz for system clock. The modified configuration can now be generated and MCC closed. Return to the device_config.h file and note the xtel_freq has now been adjusted to the 16 million as expected. Open the mcc.c file and note on line 61 the OSCON register is now equal to hexadecimal 78. This has adjusted the IRCF to the 16 MHz from our MCC internal clock selection. This could also have been edited from within the device_config.h and mcc.c files, and then built and programmed to the device with the same result. If this manual method is used, be aware that the previously generated MC3 file will not have been updated. So, if returning to the MCC, the old 500 kHz system clock and the default OSCON register value would be used. The 16 MHz manually entered xtel_freq and the OSCON register adjustment would be overwritten if MCC configuration is regenerated. We will have a closer look at this in the following tutorials. This concludes the LED tutorial versions for the PIC12 F1572. I hope the first 3 tutorials for the PIC12 F1572 have given some insight as to the differences in various methods available to achieve similar results. The various methods may seem detached from one another at this stage. We will need to delve deeper into the assembly version to cover delays and other aspects not yet touched on. For the next release of tutorials, the 14, 20, 28 and 40 pin PICs will be used, each in their own playlists. There will also be tutorials for the development board series using the PIC Micro X kit and the same PIC devices, each in their own playlists. Thanks for watching. Please leave a comment or suggestions to help improve the content.